All right, so let's do some more simplifying of complex rational expressions. So we left off kind of getting into a few harder problems, and now I'd like to challenge you and kind of work through a couple with me. So our first problem, and I guess if we were keeping in line with what we did before, this would be example 4. Let's try this. 1 over x minus 1 over y all over x squared minus y squared all over xy. So you can see in this problem that in the numerator, we have to figure out what our common denominator would be. And if you think about it, it's just going to be the product of this denominator times that denominator. So I know that my common denominator on my numerator is going to be xy. Okay, so now think about if we have xy in the bottom, what did we do to get that there? Well, we have to multiply both sides by y over y to get that. You know, that's how this becomes this here. So on the top then, you'd have y times 1. Now for the second one, we had to multiply the top and the bottom, by x over x. So that would be 1 times x, and then the xy on the bottom. Okay, so now on the bottom in our denominator, that's already pretty nice because we just have this xy term, so we don't really need to do much just yet. So for right now, I'm just going to rewrite that as x squared minus y squared all over xy. Okay, and then let's look at that top again. So now I can simplify that down. Y times 1 is just y, and 1 times x is just x. So I have y minus x all over xy. Now, I don't know that it's necessary to write it every time that you do this, but basically what we are going to do here is we're going to multiply, okay, by the reciprocal of the denominator again, okay, to cancel that out. So over here, I have an xy on the top, okay. And then if you look at this really closely right here, you'll notice again that it's a what? That's right, a difference of squares. So I have x plus y and x minus y. And then we can go ahead and start canceling out terms. So I have xy over xy. And now, hopefully here you see something. You're like, I might be able to cancel out something. It seems like I should be able to do something with this and this. And if you see that, you're absolutely right. What that simplifies down to is minus 1, okay? So if you think about factoring out a negative on the top, okay? So if I factored out a negative on the top, that would leave me with a minus y plus x, okay? And then on the bottom, I would have an x plus y times an x minus y. Well, look at the top term, the minus y plus x. Well, you can rewrite that, right, as x minus y. So this cancels with this. And then what you're left with is just a negative 1 all over an x plus y. And that works every time. That just kind of comes from, well, the general definition looks like this. Let's see here if I can pull up a new slide for you. Okay, so it kind of looks like this. It says, if you have something like a minus b all over b minus a, that equals a negative 1. Okay, and that's where it comes from. If you think about yanking that negative out on the top, you have a negative minus a plus b, okay, well, and then all over, of course, b minus a. And then if you just think about rewriting that top so that your b is first, you'd have b minus a all over b minus a. So you can see then how that equals -1. So that's just kind of one of those things that you'll slowly learn over time. And if it looks like that and you're going, oh, I know I can do something, having this definition or kind of trying to remember that is a really, really helpful way to simplify. So I hope that that helps. Now let's look at another problem that's a little bit more complicated yet. So this would be example 5. Okay, and in this example, we have to do a little bit more work, okay? So here's what it looks like. Y squared minus y minus 6 all over y squared minus 5y minus 14, okay? And then all of that is divided by y squared plus 6y plus 5, okay, all over y squared minus 6y minus 7. And now you might be asking yourself, what the heck? What am I going to do? Where do I start? Well, if you're given polynomial equations like this, the very first thing I checked for is, can I factor it? You want to factor when possible. And because we already know how to factor, I'm not going to go into great detail on that. I'm just going to work that out for you. So if you want to try this on your own, try to factor it first. Now would be a good time to pause the video, and then I will go ahead and show you what these all factor into. Okay, so here we go. In our numerator, you'd have y minus 3 and a y plus 2, okay, all over a y minus 7 times a y plus 2, okay, and then on the bottom we've got, so this is our big division line, okay, big division line, okay, and then on the bottom, oh, my equals went away, we have a y plus 1 times a y plus 5 all over a y minus 7 and a y plus 1. So now you might be going, well, that's great. I have it all factored. What do you do next? Well, this is where we multiply again by the reciprocal of the denominator. And so if you do that, we know that all of this whole bottom is going to go away. Okay, so basically you're flipping that, and what it looks like if you flip it is this: y minus 3, y plus 2, and now I'd have to multiply that by what's here, so you'd have y minus 7 times y plus 1, okay, on the top, and on the bottom, starting with this right here, okay, so you'd have y minus 7, y plus 2, and then we get a different color, and then we'll finish it with that, so then you'd have y plus 1, y plus 5. And then the really fun part begins, right? Because now we can just cancel. So that y plus 1 cancels with that. The y plus 2 there cancels with that. And then I've got a y minus 7 that cancels with that. And then you're left with the y minus 3 over the y plus 5. Okay, so hopefully that helps you guys to kind of get a jump start at least on how to work with complex rational expressions. So good luck, and let me know if you have questions. I'm always happy to go through more examples.